going to begin with a problem that involves similar triangles. Now the word similar in geometry basically tells you that the triangles are of the same shape but not necessarily the same size. Notice in the picture below that the two triangles that I've got drawn here are basically of the same shape. It's as if one is an enlargement and the other is a reduction of the other. Now let's make up some numbers here. Let's say I give you that two sides of the first triangle are 8 and 10, and two sides of the second triangle are 3 and x. Notice how I have the two triangles lined up so that corresponding sides match up with each other. I'm going to just draw a line in to line these babies up and have a proportion set up that way. This way I can have 8 over 10 equals 3 over x. And I'm going to basically multiply through by the least common denominator of 10x to clear the fractions. On the left hand side, I'm going to get the 10's canceling, giving me 8x, and on the right side the x's will cancel, giving us 30. So x is going to equal 30 divided by 8, which is 15 over 4. If you need that in decimal form, that would be 3.75. Now, when I lined these two up, notice how I have top left matching with top left, bottom or base matching with base, and that's in the same arrangement over here. Well, the same thing is going to be true a little bit later on. We always want to make sure we line up corresponding parts. This next problem does not have a picture drawn for us. At the same time that a yardstick casts a 6-foot shadow. Well, here's my little yardstick. It's 3 feet tall because a yard is 3 feet. It's going to cast a 6-foot shadow. A tree, not drawn to scale, is going to cast a 30-foot shadow. Now, the words "at the same time" are an important phrase in that problem because the sun has to be at the same point in the sky so that the angles within the triangle, that right here is called the angle of elevation, that needs to stay the same within both triangles. We are trying to find the height of the tree, which I will call h. Now in this problem you can just say, oh, look at the denominators, or look at the bases. The 30 is 5 times the 6, so I bet the height is 5 times the 3 and get a 15 feet that way, and that would work. If the numbers didn't line up so nicely, however, I would create a proportion in much the same way that we did the last problem, lining up corresponding sides. 3 over 6 is equal to h over 30. And multiplying through by the least common denominator of 30, the 6 and the 30 are going to cancel on the left, giving me 5 times 3, which is 15. And on the right, the 30s cancel, giving us h. So 15 feet would be the height of the tree in that problem.